All right, here is our lecture video for section 10.5, apply other angle relationships in circles. So we're still talking about angles inside circles. So we still have a few more theorems that we're going to talk about in this section. So here's our first one. Before we dive into it, just remember that the measure of an inscribed angle is half the measure of the intercepted arc. So that was the theorem we learned in section 10.4. So moving on today, our new theorem. If a tangent and a chord intersect at a point on the circle, then the measure of each angle formed is 1/2 the measure of the intercepted arc. So we're sticking with the 1/2 measure of the intercepted arc. So that makes our life easier because it's the same as the last theorem we had with inscribed angles. But now we're talking about this angle created between a tangent and a chord. So remember, a tangent is outside the circle and intersects the circle at exactly one point, and the angle created by this chord right here is going to be 1/2 the measure of that intercepted arc right there. So still dealing with 1/2 the intercepted arc. So let's see what this looks like in an example. Example 1. Line M is tangent to the circle. Find the measure of the red angle or arc. So they're telling me that this line right here is a tangent, so we're dealing with that theorem we just saw. And we want to figure out what this angle right here is. Well, we know that a chord intersecting a tangent is going to create an angle that's 1/2 the intercepted arc. So we can do 1/2 times the intercepted arc, which is 130. To get that angle 1 right there is going to be 65 degrees. And we're done. Simple as that. Part B, kind of thinking along the lines of it being backwards. Now we want to figure out, well, what's the measure of the arc now if we know that the angle is 125. And just like we did in the last section, well, think backwards. That angle is 1/2 of the arc. So if we multiply the angle by 2, we know that the measure of that arc is 250 degrees. And that's how we're going to work with this theorem here. So why don't you guys try these 3 on your own and come back when you're ready to check your answers. Okay, measure of angle 1. Well, they tell us the arc is 210 degrees. So if I take 1/2 of 210, I get that angle 1 is going to be 105 degrees. And for this one, they want the measure of angle R, or arc RST. Okay, well, they give me that 98 right there for the angle, which I know is 1/2 this whole arc. So if I do 98 times 2, I get that the measure of the arc will be 196 degrees. And then over here, looking at the measure of x, y, well, we have 80 degrees here for the angle. So just like we did in the last example, we can do 80 times 2 to get that arc XY is going to be 160 degrees. And that's the basics with working with this theorem. We're not going to stray too far from that. So remember, we have a tangent and a chord that intersect. The angle they create where they intersect is 1/2 the measure of the intercepted arc. Very similar to what the theorems we learned in section 10.4. So moving on, before we jump into our next theorem here, let's just kind of think about this for a second. Intersecting lines in circles. If 2 lines intersect a circle, there are 3 places where they can intersect. They can be on the circle, inside the circle, or outside the circle. And we're going to learn 2 theorems that deal with these different cases. When it was on the circle, that's what we've been working with inscribed angles and our last theorem. Our next 2 theorems are going to jump on when it's inside the circle and outside the circle. So our first one, angles inside the circle theorem. If 2 chords intersect inside a circle, then the measure of each angle is 1/2 the sum means add, of the measures of the arcs intercepted by the angle and its vertical angle. So take a peek over here. Say we want to find the measure of angle 1 right here. What that theorem just told us is that the measure of this angle right here, since they intersect inside the circle, is going to be 1/2 the sum of its intercepted arc and its vertical angles intercepted arc. So think opposites intercepted arc. So if we intersect inside the circle, this angle right here is 1/2 the sum of its intercepted arc and its opposite angle, its vertical angles intercepted arc. Now, say the two lines intersect outside the circle, we have this theorem. If a tangent and a secant, two tangents or two secants intersect outside a circle, then the measure of the angle formed is 1/2 the difference, difference means subtraction, of the measures of the intercepted arcs. So say we have an example like this, angle 1 is outside the circle. To find its measure, we would say, okay, it's 1/2 the difference, do big minus small. Angle 2, just a little bit different situation here. To find its measure, we would do 1/2 the difference, big arc minus small arc. In another scenario, we might see angle 3 is still 1/2 the difference, big arc minus small arc. And we are going to work with this and be able to solve for different things. So basically, if the chords intersect inside the circle, it's the sum. If they intersect outside the circle, what's the difference? That's really the only big difference here. Everything else kind of stays the same. That kind of formula format stays the same. So let's try a few examples here. Example 2, find the value of x. So x is an angle over here, and we have two chords intersecting inside the circle. So we know we're going to be working with the sum, and we know that that angle right there is going to equal 1/2 the sum of its intercepted arc, 156, and its vertical angle, so here's its vertical angle, that intercepting arc, the opposite intersecting arc, so 130, and we just got to solve. So do a little addition here, 156 plus 130 is 286, and 1/2 of that is going to give us 143 degrees. And that's what we're working with here. So what if we intersect outside the circle? Let's see an example with that. So we're still finding x, and as you guys can see, it's created outside the circle. So since it's outside the circle, we are going to be thinking of difference. We're going to subtract. So we know that x is going to equal 1/2. Always have that 1/2 out in front. The bigger arc, so 178, minus the smaller arc, 76, to get that x equals 1/2 of 102, which is just 51 degrees. And we're done. All right. And that's kind of all we're going to really dive into with these types of angles. If you would like to see a more complex, harder example, word problem worked out, this will be worked out in the lecture notes, but I'm not going to do it in the video because this is way more complex than what we're actually going to get into. So just to make sure that you guys have it, you understand what's going on, I want you guys to try these two guided practice examples right here on your own and solve for the variables and come back when you're ready to check your answers. Okay, so number 4, we need to solve for y, and we have two lines intersecting inside the circle, so we know we're going to be working with the sum of this arc and that arc, but the only thing is the angle that's related to that is this angle right here, or its vertical angle, not the 102, but this is a linear pair, so we know that to get the other angle, we could do 108 or 180 minus 102 to get that this angle right here is 78 degrees. And now we can use that formula that we learned, and we know that, well, that angle, so 78 equals 1/2 the sum of its arc, 95, plus the opposite arc, so plus y, and then we're going to have to solve for y here. You could distribute this 1/2, but then it kind of makes it a little bit messy. We did this with the mid-segment back in chapter 8. If we multiply both sides by 2, it gets rid of that 1/2, and then the 78 becomes 156. And we're just left with 95 plus y over here. So then we can just subtract 95 to get that y equals 61. And that's going to be the hard problem we're going to see with this. We're going to keep this stuff pretty simple. And that's going to be one of the more difficult ones you see, where you just have to realize, oh, this is still just a linear pair, so we can just do 180 minus that to get what this angle is. So number 5, moving on, this intersects outside the circle, so now we know we're going to be doing the difference, and they give us the angle again, so we know this is going to be 30 equals 1/2 big arc, so A minus small arc, 44. This order is important, so remember it's the big minus the small. So again, kind of the same solution process we just saw in the last example. Multiply by 2, the 1/2's gone, multiply by 2, we get 60 equals A minus 44. We add 44 to get that A is 104 degrees. And that's really it for this section. So here is your homework for this section, page 675, number 3 through 11 odds. Again, we're just going to keep it on the simpler side of things. These are going to be one of the more difficult type problems you're going to see, like we just did. So email me if you have any questions.